Hello friends, once again I came with a new video, and this time you can see I have made this OnStep GoTo mount. And friends, I am sure you know what is a GoTo mount. It is very useful to find any celestial object in the night sky. You just have to click on your desired object and the mount automatically point the telescope to the selected object. And it has tracking mode also, so you can do astrophotography also with it. So friends, in this video I will show how I made this OnStep GoTo mount. So let's get started. So first I download the OnStep code from github.com. And now I will open it. And here you can see the downloaded file. And I have to extract the file. And now I am going to rename it by OnStep. And open it. And here you can see OnStep with Arduino icon. Just click on it. And I have already installed Arduino IDE software in my PC, so it will opens automatically. And here you can see it opens, and you can see it has many pages. And this is the configuration page, and I have to modify this configuration page little bit according to my mount design. And now I am going to gear ratio calculations for array axis and deck axis, and the first one is for array axis, and you can see a number of 12,800. To find this number I have to download the OnStep configuration calculator, you can see. And here you can see I have downloaded the Excel spreadsheet of OnStep configuration calculator in my mobile. And you can see the two columns of gear reduction, GR1 and GR2. And now I have to put the values according to my worm gear design. And here you can see I am using two worm gears for each axis. This is a metal worm gear. I bought it from Amazon and it has 40 teeth. And it is its worm. And this is a 3D printed plastic worm gear. I also brought it from Amazon. It has 18 teeth. And now I am going to put the teeth numbers of my worm gears on the spreadsheet. And here you can see the driver macro steps column, and you can see the number 32 is already filled up by default. And as I am using DRV8825 driver, so the number 32 remains the same, because the driver DRV8825 can give maximum 32 micro steps. And this is stepper steps column, and this is my stepper motor specification. And here you can see steps per revolution is 200, so I will put 200 on this column. And after putting all the numbers, I got these three values. And I have to put these three values on configuration page. And you can see I got 12,800 steps per degree. And you can see there is already the number 12,800 filled up by default. And here you can see another number, steps per worm root, and I have to put this number here. And here I have to put the driver model name, DRV8825. Here you can see driver macro steps, and as I found the driver macro steps is 32 on the configuration calculator, so I put here 32. And same modification has to be done for axis 2 or deck axis. Okay, so all the modifications completed. Now I have to select the board. And you can see My board is ESP32 dev module is already selected here. And here you can see I connect my ESP32 board with my PC through a USB cable. And now I am going to upload the code. And first I have to verify the code. And then click on upload. And you can see the code is uploading. And done uploading. And this is the circuit on a breadboard. This is ESP32. And these are the two motor driver DRV8825. And here you can see the circuit diagram. And you can see I connected two stepper motors to the circuit and power the circuit for testing. And now I will open the OnStep app and connect it via Bluetooth. And you can see the OnStep interface. And you can see it gets connected. And now I will check whether it works or not. You can see the array motor is moving. And you can see the both motors are working. And you can see the tracking mode also working. The array motor moving very slowly. And this is my stepper motor, and you can see it has 6 wires. Out of 6 wires I am using 4 wires, you can see, rejecting these two center tape black and white wires. And this is a shaft coupler. I bought it from Amazon. And here you can see I inserted the narrowed shaft into the small worm and fixed it with M-seal glue. And here you can see some rubber pads. I will keep 3 rubber pads inside the motor housing so that they can absorb the motor's vibration. And similarly I made another box for array axis, you can see. And you can see I arrange a hole across the deck axis box so that array axis pipe can enter into it. And here you can see I made a fixed equatorial edge of my latitude angle. And I will keep my array axis box on it and fix it with glue. This is 12 volt power supply and this is 5 volt. I arranged the 12 volt and 5 volt power supply separately. And here you can see the circuit board inside this chamber. And you can see array motor is connected with the circuit through this hole. And you can see the array axis was not in the center before, so I had to add some extra mass. Here you can see, to balance it properly. And you can see it is balanced. And now I am going to switch on it and show you how it works. And here you can see the OnStep app. And you can see it gets connected. And first I have to set the date. And then reset home. Solar system. Now it is daytime, so I click on the sun. Go to. And you can see go to started and telescope slowly moves to the sun. So friends, how was my video? Please like, share and subscribe my channel. Thanks for watching.